I think 6.3 will take a little bit longer. 6.2 should not. There are going to be things in 6.3 that we're going to kind of, I don't want to say skip over, but how we've been taking the derivative, these easy functions or whatever. There's some more advanced functions in 6.3 that we're just going to say, okay, this is the derivative, and you guys are just going to have to trust me. Otherwise, it's going to take 20 years to do that. What I may do, it's questionable, is go through and take those derivatives and just make copies of it and pass it out to you so that you guys can see that, just because you would have to use like chain rule or product rule, and it's going to take a long time. But we already know how to take those derivatives. So I feel like it's wasting your time to do that, but it might be worth it for you to see it. So I haven't really super decided yet, but 6.3 is the only one that I feel like you would have questions about. So 6.2 differential equations, growth and decay. I don't think there are any that we have to, let me just check to make sure. Okay, there's like one that we have to set up. The rest of them are normal equations that you should know the equation to. So next section, you're gonna have to set up the equation by yourself, okay? Obviously, you're gonna set it up with me during notes, but I will teach you how to do that. So this one is a little bit more cut and dry, and then the next one, like it's gonna give you the word problem and you have to set up the equation by yourself based on what the word problem tells you. So that's why I said it might take a little longer. It's not that it's so much more content. It's just that we're going to take it a lot slower. Does that make sense? Is everybody good with that? So probably looking at test next Wednesday at the earliest, So that would be 6.3 Friday and Monday, and then review on Tuesday, test on Wednesday at the earliest. Okay, so could it be pushed back? Yes, but we gotta get moving and make sure that we can finish this content. So earliest Wednesday, latest Thursday. Everybody good? All right. In section 6.1, and I apologize, like I don't know if it's all the talking that I did yesterday. I don't know. By second period, which is not a lot, like I like cough drops and craziness because my throat was getting dry. So I apologize if I like cough or do anything. I'm not. It's just nature of the beast, I guess. After being out for 2 weeks and not talking, I just sound ridiculous. So I apologize already. In section 6.1, you learn to analyze the solutions visually of differential equations using slope field and to approximate solutions numerically using Euler's method. Analytically, you have learned to solve only two types of differential equations, those in the forms of y prime equals f of x and y double prime equals f of x. In this section, you will learn how to solve a more general type of differential equation. The strategy is to rewrite the equation so that each variable occurs on only one side of the equation. This strategy is called separation of variables. Sorry, I definitely spelled that wrong. All right. So solving a differential equation, you have y prime equals 2x over y. And we have x and y on the same side, so we want to try to get those y's together and the x's together. So what we're going to do is we're going to multiply by y. To get that y prime times y equals 2x. Since we don't have the y prime or anything like that, like yesterday they were giving us things, we're going to integrate this. So we're going to do the integration to get rid of that prime. So remember that we can rewrite y prime as dy over dx. And then y dx because we're taking the integration with respect to x. Is also going to equal the integration of 2x dx. So I just wanted to show you that we were taking the integration. Then remember, when you take the integration, you're going to write that dx part. Then, just like a regular algebra problem, if there's a dx on the bottom and a dx on the top, it will cancel out. So this leaves us with the integration of y dy equals the integration of 2x dx. Anybody have any questions about that? Let's remember that we're not supposed to have our phones out, not supposed to have earbuds in. Guys, make sure that you do that. I'm not going to be too strict on it the next couple days, but once, like I said, once I get the pockets and I can treat you like fourth graders, you'll put them up there. Okay, is everybody good? Sorry. Also, drinks should have lids. Guys, we're old enough to follow rules. Yes, old enough to follow rules. Go ahead and integrate this. How do I integrate y dy? How to do the integration of y? We should know how to integrate it. What is it? You knew how to do the derivative, and derivative was before integration. Integration was what we just did. Oh, I squared over 2. Integration of 2x dx. And then we're going to put our c, and I'm going to put c1 there. What can we do to clean this up? Cancel out your 2's, or we can multiply by 2. Oh, you're talking about these 2's. Sorry. I'm with you. I'm with you. Still the same thing. And then we want to get C1 by itself. So there's your differential equation. If you go ahead and multiply that 2C1 by 2, it's still going to be a constant. Does everybody understand that? So it's not wrong if you put the 2 in front of it, but there's no point in doing it. Does everybody understand that? So just leave it as C1. All right. So that's basically what you're going to be doing. For your growth and decay models, you learned a growth and decay formula in Math 1. You worked with it in Math 3. I cannot remember if I did it in pre-cal or not because everything is blurred. So that's what you're going to work with. When I said that's the general equation you're going to work with today, you should already know you're going to use it over and over again today. In many applications, the rate of change of a variable y is proportional to the value of y. When y is a function of time t, the proportion can be written as shown. dy over dt equals k times y. The general solution of this differential equation is given in the next theorem. So if y is a differential function of t such that y is greater than 0, and remember dy over dt, we can change to y prime, it's the derivative, equals ky for some constant k, then y is going to equal ce to the kt where C is the initial value of T. And K is the proportionality constant. So this is a formula that we're going to use in basically the whole set of notes. Exponential growth occurs when K is greater than 0. And you should know that. Obviously, if it's bigger than 0, it's growing. And exponential decay when K is less than 0. So it says the rate of change of Y is proportional to Y. This part right here is this. Okay, the rate of change, remember, is the derivative. The rate of change is the slope. The slope is always the derivative. Does everybody understand that? So that's where the Y prime is coming from, or the dy over dt. And then proportional to Y, so K is your proportionality constant, and then your Y. So when T equals 0, Y equals 2, and when T equals 2, Y equals 4, what is the value when T equals 3? So you're just going to keep plugging in. So this is not hard work at all. Okay, so understand that. So we're going to start, instead of using this formula, we're going to use this one. But this sentence right here helps you recognize that you're going to use this as your Y equals. Okay, you don't have to do the differentiation on this at all. Where did this equation come from? It came from the differentiation. Does everybody understand that? Or the integration, sorry. So anyway, I didn't show you that because we did that yesterday in our notes. So Y equals CE to the KT. Start with the first thing that they give you. So this one is the first thing that you're going to do. T is 0 and Y is 2. So Y is 2. We have CE. We don't know K, but we know that T is 0. What's going to happen up here? 0 times K is 0. There's nothing that we can do, right? So it's not going to be anything. Anything to the 0 power is what? Everybody understand that? So I wanted to put that in there just so you could see it, which means that C is 2. Now in our equation, we know what C is. Everybody understand? So that was the whole purpose of solving it the first time, was to get C, if you want to put a little 1 as a reference. Then we're going to do this in number 2, but we also know that C is 2. So we're going to redo it. Again, not hard work. You just got to keep plugging into the formula. Our new Y is 4. Our C this time is 2. E to the K, and our T is 2. You want to get E by itself. So how do I do that? Don't make it complicated. This is easy math. So don't quit thinking calculus. Does everybody understand that? We're just solving problems now. Divide by 2. And I'm going to write it all out in your homework. You don't have to write out the divide 2 if you know that it's divide 2. We get 2 equals E to the 2K. How do I get rid of the E? LN both sides. If you LN both sides, LN and E will cancel out. And you're left with LN2 equals 2K. How do I solve? And again, I'm going to go ahead and write it out. You don't have to. You already know that. Then go ahead and put it in your calculator. You can leave it as LN2 over 2. So if like this was the calculator inactive part, you can leave it like that and it'll be fine. Don't stress out about it. They don't care. But if we're going to do calculator, I'm going to go ahead and put it in. LN2 divided by 2 gives me 0.3466. I would suggest going forward decimal places all the time from here on out. Then we have one more condition. It says, what is the value of y when t equals 3? So this is your last part that you're going to do. You're going to do that same formula. But the thing is, you know everything except for y. So we're just plugging in. What was c? They told us t was 3. What did we find out k was? And t was 3 in the very last. So it's literally, sorry, just plug into your calculator. 2 e to the 0.3466 times 3, which gives us 5.6573. That's it. So did we do hard math? Not at all. So this is basically what you're doing in this whole section, literally plugging in multiple times. Now, what's the difference in 6.3? You have to set up your own equation and you have to get it into y equals and then work on it. Is that right? Good. All right. Next. 10 grams of plutonium isotope 239 Pu were released in a nuclear accident. How long will it take for 10 grams to decay to 1 gram? The half-life for plutonium is 24,100 years. So same exact formula. We talked about growth and decay. So anytime it talks about growth and decay, we're using that same formula. What's the difference? K will be what? Negative, less than 0. Does everybody understand? So you use the same formula, it doesn't matter. So what was our formula we're using? CEKT. Well, what's our first condition? Okay, that's the question we want. But what would be our first thing that we're plugging in? Because it didn't spell it out for us. It didn't say this and this and this and this and this. What was let me try this again. What was our first condition in the last one? We found C. How do we find C? Why was it easy to find C? Yeah, they gave us everything here. T equals 0, right? What does that mean? What does T stand for? Time. What does 0 stand for? No time has passed to the beginning, right? What's our beginning? Right? Time is 0. What's our beginning? 10 grams. So they did give it to you. Does everybody see that? So your first condition is that we had 10 grams at the start. Does everybody see that? Okay, so they did give that to you. So our y is 10, CE to the K times 0. What happens to your EK0? It just basically cancels out because it's 1, right? So 10 equals C. I worked it out on the first one. You don't necessarily need it now. All right. So then what's our next condition that they give us? They do give us another one. Okay, so they give us the half-life. So what does half-life mean? What's divided by half? Okay, so what is our new y going to be? 5. And how long is that going to take? Does everybody understand that? So even though they didn't like spell it out for us, like little kids, we can get it right. All right, just remember that. So then we're going to plug it in. Y is 5. We got that C was 10. E to the K times 24,100. What are we solving for in this? And we said that K should be what? Negative. So make sure when you finish that you should have a negative number, right? All right. And it might be a really crappy one because anytime you're dealing with half-lives, it's going to be crazy. Okay. So divide by that 10. We get 1/2, or I'm just going to put 0.5. E to the 24,100 K. How do I fix it? LN. LN 0.5 equals 24,100 K. Okay, what do I do now? LN 0.5, 24,100. Check that out. What does this mean? Yeah, we have times 10. It's, yeah. So move that decimal place, switch way. Yeah, so this is going to be negative point. You'll have 4 zeros in front of 2876. So whatever your E is, it's one less zero in front. Okay, whatever your E is, it's one less zero in front. And we did get a negative, so that's good. All right, so it wants to know how long will it take. So now what are we looking for? We're actually looking for T, so we haven't solved for that yet. So we're going to do that. So in the third one, we need to find out what T is. What does it ask us to do? So here's what I'm saying. If we're solving for T, we need Y, C, and K. We know what C is. We know what K is. What is Y in our last one? 1, because we want it to decay to 1 left. Does everybody understand that? So Y equals CE to the KT. We want 1 gram left. What was our C? We started with 10. E, our K is that negative 0.00002876. And then we have a T. How do we solve? Divide by 10. We get 0.1 equals E to the negative 0.00002876 T. Then what do we do? LN. So LN makes the E go away. We get LN 0.1 equals negative 0.00002876 T. And then the last thing we do is blah, blah, blah. And when I put that in my calculator, 0.1 divided by negative 0.00002876. I get 80062.0686, or approximately 80,062 years. It's a long time. I'm good with just the T. I don't have to approximate it. But again, if you're doing like a multiple choice and it says approximately whatever. If you go back, which some of you do, some of you don't, and you look at your examples in your book, it gives you 80,059 years because they don't use as many decimal places as I do. So don't stress out. It's about the same. Is everybody good? An exponential population of fruit flies increases according to the law of exponential growth. There were 100 flies after the second day of the experiment and 300 flies after the fourth day. Approximately how many flies were in the original population? So same formula. What do we know? What's the first thing it gives us? What are those variables? And is everybody good with that? Okay. Y is 100. T is 2. What's different about this one? It's not 0, so we're not going to get a definite C. Does everybody understand that? Can you still get it? Yes, it's just going to have a variable in it that you have to plug in for. So don't stress out. It's the same exact process. You're just going to have that K left. Don't stress out. Okay. So how do I solve this? Just like normal. How would I solve for C? That's what I'm looking for. You know how to do this. It's not a hard question. Don't stress out because you can't get rid of it. So we're just manipulating that equation. Okay. Now, they make it a little bit different in your book because they don't like to work with fractions. And if you don't like to work with fractions, that's fine as well. So what they actually do is they move it up and they make that power negative. You do not have to, by any means, you do not have to, but it might make it look a little easier to you. Okay. So there's the first one. We solved for C. What do we do on the second one? What do we know? We know that C is 100 e to the negative 2k. What else do we know? Y is 300. And T is 4 this time. So we're going to plug in into our equation. Y equals CE to the KT. You said Y was 300. C is 100 e to the negative 2k. I'm going to put that in parentheses to kind of separate it. You do not have to. E to the 4k. Yep. You can put these two together. How do you put it together? So like if you had x to the negative 2 times x to the 4th, what would you have? X squared. X squared. Remember, the 2 will go on the bottom. If it's the same on the top and bottom, you can mark it out. Does everybody understand that? So this would be the same thing as like x to the 4th over x squared. If you can see it a little bit better like that. I don't know what you like. Otherwise, you're adding them up. So this is going to change into 300 equals 100 e to the 2k. And now we can solve. How do we solve? Divide by 100. And again, you don't have to show all these steps in your homework. I'm just doing it so you can go back and look and say, okay, I know where she got that from. How do I solve now? So I get ln 3 equals 2k. And then ln 3 divided by 2. Thank you. Highlighted today.
I worked like 2 minutes on
75. All right. So our last step, let's finish this up. I'm gonna drop down to the bottom and do our part 3 down here. It wants to know how many flies were in the original population. You can use either one of the Ys or Ts that you already did. I'm gonna go back to number 1 and use that Y and that T. It doesn't matter which one you choose. Does everybody understand that? It doesn't matter. You could use 102 or you can use 304. So I'm gonna give you the same thing. So I'm gonna start with 102. Right here, it said C is 100 e to the negative 2k. We know k now. So everybody understand that? So I can go back up here and know that C is e to the negative 2 times 0.5493. So 100 e negative 2 times 0.5493, which gives me 33.3337. That's already my C. I don't have to do any work. I'm going to show you how to do the work without doing that so that you guys can see. Okay, so just in case this comes up and we don't have anything here, this is your answer. This is fine. If we do it this way, our K was 0.5493. With our flies, it was 102. We're going to divide. And we're still going to get that C is 33 point blah, 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 blah. So it doesn't matter which way you do it. I don't care. But you can, again, pick either one of those or you can just plug it into C. I just want to make sure you understand. We're just going to keep plugging in to the whole problem. The next one is easier, but it's the same. Ready, go to the population growth, this one. 4 months after it stops advertising, a manufacturing company noticed that its sales have dropped from 100,000 units per month to 80,000 units per month. The sales follow an exponential pattern of decline. What will the sales be after another 2 months? So we're going to use our formula again. What goes where? Sorry. Which one? It's not the Y. Why is that not the Y? Nope. See? Why is the 80,000? Because that's the ending. So you think about that. Why is at the end of that? We want the end there. What is C? What is C? What is it in general? Guys, we've been doing this for like 4 problems now. What was C? It's where we start at, right? So how much did they start with? That's why it's your 100,000. So C is always what you start with. You need to write that down. Guys, make it. This is the end. This is your start. So that's why we're putting it in the way that we are. So when they looked at this, it ended at 80,000 because it was decaying, and it started with 100,000. That E is not going to change. What else do we know? Okay, so what's 4? Good. And then it wants to know what the sales will be after 2 months. So that will be our second equation. Okay, so how do we solve this? Divide by that 100,000. And again, I'm going to do the work, but in your homework, you don't have to. You have a squeaky desk. Not this time.
That's all I listen. I'm writing things a lot.
What's that got to do with this week?
It sounds like somebody's erasing.
Oh,
Not you writing your voices.
LN both sides. We get LN 0.8. It doesn't matter. And then divide by 4. And I'll go ahead and tell you that K equals negative 0.0558. So now that we have K, we know that our time that we're looking at is 2 months. We want to know what it is after. So what is it in the end? What was it in the beginning? 100,000. Should it be more or less than 100,000? Less, because it's declining, right? So make sure that you have that. So E to the 2 months and K is 0.0558. That's literally just typing into your calculator and you get approximately 71,500. And again, that might number, I don't know, it might be a little off because again, I round a couple decimal places more than what they do sometimes. Oh, see, mine is a lot different. It's all good. Let me change this. You guys can keep it. You can keep it. I'll use these next year, so I want to make sure that I have the right number. All right. Look at your next one. In the previous examples, you did not actually have to solve the differential equation y prime equals ky. The next example demonstrates a problem whose solution involves the separation of variables technique. This example concerns Newton's law of cooling. Which states that the rate of change in the temperature of an object is proportional to the differences between the object's temperature and the temperature of the surrounding medium. Let Y represent the temperature in degrees Fahrenheit of an object in a room whose temperature is kept at a constant 60 degrees. The object cools from 100 degrees to 90 degrees in 10 minutes. How much longer will it take for the temperature of the object to decrease to 80 degrees? So with Newton's law of cooling, it told you, how do I write rate of change? In my other problems, how do I write rate of change? Rate of change is the same thing as what? I literally went over this. Remember, I told you next chapter or next section, you're gonna be writing your own problems, right? So this is the start of it. This is what they're gonna give you, and you're gonna have to be able to do it. Rate of change is always the derivative. Remember, our derivative is the slope of the tangent line. Does everybody understand that? So rate of change is the same thing as slope, which is the same thing as derivative. If you need to write that down, write it down. So we're going to have, that's where we have y prime. So rate of change, I'm going to write it up here. Is proportional to, what does proportional to mean? What am I going to put? Is equals. What did I write for our proportion on the last problem? We talked about a proportionality constant. Guys, you got to start relating this. It's got to start connecting. Go back and look. Look for the word proportionality. You had to write that. Okay, but what was your proportionality constant? Hey, so everybody got it? So that's your K. The differences between the object's temperature and the temperature of the medium. So the difference between the object's temperature and the temperature of the medium. So I'm going to put temp minus temp for a minute, and we're going to hold off on doing anything right there. So I'm going to just put question marks because it just depends on what you get right there. That's what you're going to have to do in 6.3. So you're going to have to read it. If it says rate of change, you're going to put the y prime, dy over dx, whatever you want to put is fine. And then your k, because it's proportional to, and then that little section is what you're going to have to absolutely come up with to figure out what they're asking you for. And we'll go really slow. It's not like it's a huge deal. All right. So let y represent the temperature in degrees Fahrenheit of an object in a room whose temperature is kept at a constant 60 degrees. The object cools from 100 to 90 in 10 minutes. How much longer will it take for the temperature of the object to decrease to 80? So y prime equals k. Do we know the temperature of the object? 60. Do we know the temperature of the medium? Doesn't say it. No. So here's your formula. Okay. Notice this. That's true. 80 less than or equal to y less than or equal to 100. Why did I write that? Yeah, that's the highest and lowest that we're going to look at. So y, when we finish, has to be between 80 and 100, right? So right good. All right. So then we're going to do separation of variables. So this is the whole thing that you're going to do soon. Why do we have to do this? On the last ones, we had y equals CE to the KT. So we didn't have y's on both sides. This time we have y's on both sides. Everybody see that? So I'm going to change this up into dy over dt. And then I'm going to separate my variables. I can't have y on both sides. So this is what we did in the very, 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 very beginning of these notes. How do I get this y on this side? Yep, normal divide. How do I get this dt on this side? Multiply. Basically, you're switching them. Does everybody understand that? So I'm going to do that all in one step. You have your dy. You said divide by the y minus 60. You have your k, and we're going to multiply by that dt. How do I get rid of dy and dt? Integrate it. If you want to look at it different, so that the dy is not on top, you can do that as well. I don't care. How do we integrate when a single y is on the bottom? We don't have to. How do we integrate 1 over y? Or 1 over x? Right. And it was ln absolute value of y, right? So I just want to make that note over there because this is going to turn into ln absolute value of y minus 60 We can use the u. If we use u, it's going to be y minus 60. What's the derivative or what is du? It's just going to be what? All right, Gus. Wait. We would use u, right? So somebody said use u. You are correct. You are not incorrect at all. That is perfect. But we don't have to on this one. Why? What do we do next? Take the derivative. So we would get du equals 1 dy, right? Which is exactly what we have up here. So we don't have anything that we have to fix. That's why we didn't do the u part. Do you typically do it? Yes, and you should always test. So it's good that you brought up the u, but on this one, we don't have to do it because it's already fixed up. So I just didn't waste the time to do that. That's what I'm talking about on the next one, trying to find that just y equation. We're not going to integrate and do all this craziness because it's going to take so much time to do that, but I will try to see if that I can do that and give you a little sheet of that. So ln, absolute value of y minus 60 equals, what's the integration of k? Nope. What is k? Nope, k is not 0. What in general is k? Thank you. It's a constant. So what's a constant? No. It could be any number, right? What's the integration of 4? What's the integration of 4? 4x or 4t or 4 whatever, right? So what would be the integration of k if we're talking about with respect to dt, with respect to t? When we take the integration, what do we also have to put? General. Why didn't we put it on the other side? Because on this side as well. So you don't have to put it, a constant is a constant. So what would I do if I put it on the other side? I'm just going to subtract it over. We don't want you to like get rid of it. Does that make sense? So we want it to stay there. All right. What do I do now? What I'm trying to do is get my equation, y equals. Remember, that's what we've been trying to do, y equals ce to the kt. So I don't have that yet. I need that. So how do I get this into y equals? Yes, e. So your e and ln cancel out. You're going to only have the ln of a positive number anyway, so your absolute value marks go away right now. We eat that whole side, so kt plus c goes to the top. Add the 60. Do we have our y equals there? Yeah, now we can start plugging in. So this is how we get to this very first step right here, this equation. Now it's everything that we've been doing. Okay. So let's get to here. What do we do? What do we know? Did it tell us that?
It's kept at a constant 60 degrees.
60 degrees is the temperature of the object. Yep.
10 minutes.
Okay. So 10 minutes is the time. I'm okay with that. What do we always start with? Maybe we shouldn't start with 10 minutes at a time. Maybe we should start with 0. Oh, what is it at 0? Very good. Very good. So don't forget, start at the beginning. So then 100 equals 60 plus e to the k times 0 plus c. Listen carefully. The c can go to the front. It can go to the front. I know that sounds crazy, but it can do that. You guys see how it looks just like our last one, C e to the kt. So it's the same thing. Now what do I do? What do I get? 40. What happens to your EK0? So now we have C, just like we did in the beginning. So this was our first thing that we were plugging in. What can we do now? Say it again. Your T can be 10 now. Good. And we already know C is 40. All right. So 90 equals 60 plus 40. And I'm just going to go ahead and write it as 10K, e to the 10K. How do I solve? I get 30 equals 40 e to the 10K. What do I do? Divide by the 40 and I get 0.75 e to the 10K. And then L in both sides. How do I solve? Divide by 10. And I can go ahead and do that in my calculator. Ln 0.75 divided by 10. Should it have been negative? Yeah. Why? Sorry, y'all. Negative 0.02877. Now what do we have to do? Find what? Okay, so I'm gonna go all the way up here just so I have a lot of space to do this. We have y equals 60 plus, we got C was 40, E to the K was negative 0.02877 T. So that's our formula right now. We want to know how long will it take to what? So where does 80 go in the Y? Okay. How do I solve? So I get 20 equals 40 e to the negative 0.02877 t. I don't know why I keep writing that 7 like a t. Okay. Then, and I get 1/2 or 0.5 e to the negative 0.02877 t. What do I do now? So I get ln 0.5 equals negative 0.02877 t. And then divide. I get 24.0927 or approximately 24 minutes. Now, wait just a second because you're not done with this problem. What was the question that it asked? How much longer? How much has it already cooled? How long did it cool already? You guys see that it already cooled for 10 minutes? So already cooled 10 minutes. So how much longer? So just be careful about questions like that. Say that again. Be careful about questions like that. All right. Page 394. 1931. 43 and 53. All right. You already got this.